Hey everybody, this is Sue Min from fourth period. Mr. Munson asked me to guest host for him, and I hate hearing my voice, but hey, let's go ahead and get started. There's a nice picture of spaghetti, which is one of my favorite foods, and so if you want to put it on pause and take a look at that for a bit there, you're welcome to. Otherwise, we're looking at Unit 8, quadrilaterals, and this first section's 8.1, quadrilateral basics. Let's go ahead and get started.
All right, so we're going to have some vocabulary words that we're going to come back to the sheet, but in the description box down below the video, you'll see a link to a vocabulary sheet. And so go ahead and print that up. We'll come back to the vocabulary words towards the end. Also, you'll see a link to a chart that's similar to this one that we're going to fill out. Now, if you've already gotten your packet from class, there's a chart similar to this one on the front page. Go ahead and feel free to print this one out, or you can wait until, actually go ahead and print this one out and you'll fill it out with us at the end. So, you know, in the world of science, we have graphs or charts similar to this where different, species are branched off, and so you have animals, plants, fungi, and so on. Here's animals. And so animals break out into two different categories, vertebrae and invertebrate, and then those break out into other subcategories, right? And so what we find is that for arthropods, they have all the characteristics of a vertebrae, which are all the characteristics of animals, but they have no characteristics of the things down below them, nor the things to the side of them. Okay, so we're going to have this understanding how these kind of charts work as we look through a much more simpler chart of quadrilaterals and some special quadrilaterals as we move along. Okay. All right, so we're going to start off with can we identify the quadrilateral properties? All right, so let's take a look at quadrilaterals. This is a four-sided quadrilateral. Nothing special about it. The only thing that we know about it is it's got four sides. All right, so suppose the quadrilateral has these for their angles. This is, if I wanted to find x, I see an unknown, so I'm going to have to write an equation. What we know is a property of all quadrilaterals. The sum of the angles is 360, and of course it has four sides. This right here allows me to write an equation to solve for that unknown. All right, so then I just simply solve that equation. And so just following simple algebra, I get to x equals 46.4. If I wanted to know what each one of these angles was, I would just simply plug it in there and calculate. All right, try your hand at this one, see how you do. Put me on pause. All right, so I wrote my equation. I'm just going to call the missing angle Sue Min, my host at the very beginning, and then I'm just going to calculate for that angle. All right, there we have it. Sue Min equals 98 degrees. Okay, so for the parallelogram, which is a quadrilateral, right? It's four sides. There's some properties of parallelograms that we want to note. First, opposite sides are parallel. So we use those arrows to represent parallel lines. All right, so we can mark as soon as we know it's parallelogram, then we know opposite sides are parallel. Hey, just as a note for future, as soon as we start talking parallel lines, we start talking about two parallel lines cut by transversal in that whole unit. Consecutive interior angles are supplementary and so on. All right, and so speaking of consecutive angles are supplementary, they are. So consecutive angles are one right next door to each other. And so A plus B equals 180, B plus C equals 180, C plus D is equal to 180, A plus D is 180. So it's consecutive angles are supplementary. Opposite angles are congruent. That means if this angle is 45, this one's 45. Okay, so opposite angles are congruent. And then diagonals bisect each other. That means when I draw the diagonals, they cut each other in half. Now, what's really important, sometimes students will mark, let's say this segment's congruent to this segment, and then they'll use a single mark to mark these are congruent, and that's not at all what we're looking for. What we'd want to do is just make sure that we mark the pieces, these two are congruent, and then these two are congruent. All right, so let's take a look at rectangles. So rectangles are parallelograms. So rectangles have all the properties of a parallelogram, right? The sides, the opposite sides are parallel. That's a given. We know opposite angles are going to be congruent. We know the consecutive angles are going to be supplementary. And the diagonals bisect each other. They're all the properties of a parallelogram, but they get some new features that a parallelogram doesn't have. One is, well, not only are the opposite angles congruent, right, but they're all congruent to each other. They're all 90 degrees, right? So that makes them all right angles. That's what makes it a right or a rectangle. That is the big property that every rectangle has. All the angles are 90 degrees. All right, so we have they're all congruent and they're all right, right? Then the other thing is the diagonals are congruent to each other. So if the blue diagonal's 10, the green one's 10. Now, since it's a parallelogram, we know that the diagonals bisect each other. So that means the green one cuts the blue one in half. And it means that the blue one cuts the green one in half, okay? But since both the green and the blue are exactly the same length in a rectangle, the diagonals then not only just bisect each other, it cuts them into all the parts being congruent. So instead of marking this one with a single or double strike as if it's different length, I can go ahead and mark it as the same length as the other ones. So if I had a four-sided figure that was given to me and the diagonals were marked as being congruent like that when they're bisected, I would know that that's a rectangle that's drawn really lousily. Okay, if you allow me to use that word. So I can tell by the properties of the diagonals that it's a rectangle. Okay? All right. So that's all the characteristics I need you to know for a rectangle. Let's move on. All right, so let's take a look at a rhombus or a rhombi. So a rhombus, rhombi is actually plural. So rhombus is a singular. So anyway, it has all the properties of a parallelogram. The opposite sides are parallel, right? We know that. The diagonals bisect each other, so we know that. The opposite sides are congruent, okay? We know that. Now we're going to talk about the opposite sides being congruent at a higher level for a rhombus. They're congruent. Opposite angles are congruent. Consecutive interior angles or consecutive angles are supplementary, and so on. So we need to understand what the properties of parallelogram are so that as we move into it being a rhombus, we know what features happen for it that are specific to it being a rhombus. So first of all, opposite sides are congruent is a feature of all parallelograms. But in a rhombus, what we find out is that all the sides are congruent. So it's another added feature that they're all congruent. Okay? So that's specific to a rhombus. Then another added feature is that the diagonals are perpendicular to each other. Okay? So when they meet, they form a right angle. Now, I'm hopeful that you'll see that I have a triangle now with a right angle in it, and of course all these are right? And so we could possibly run into problems where we're now using right triangle information, Unit 7 stuff, trig, special triangles, the Pythagorean theorem, things like that, to figure out some missing pieces, okay? So we have to know and remember that in a rhombus, the diagonals are perpendicular. All right, so if we look at a square, we find out a square has all the properties of a rhombus and a rectangle brought into it. Okay, so whatever a property is that exists in a rhombus exists in a square. All the properties of a rectangle exist in a square. Okay, so for instance, first of all, it's a parallelogram, so we know opposite sides are parallel, right? That's the feature of a rhombus and rectangle because those are parallelograms. And so on. All the diagonals bisect each other and the whole list continues. The square incorporates all the rhombus and rectangle information into the two big features of a rhombus that we get is that all the sides are the same. Not just opposite sides are the same, but all the sides are the same. And that the diagonals are perpendicular to each other. And in a rectangle, we find out that uh, in a rectangle, the feature that gets added is that all the angles are right and that the diagonals are congruent. So in other words, when they get bisected, all the diagonal smaller pieces become congruent to each other. Okay? Now I need to go back and add one more feature to the rhombus that I forgot. All right, so flip back to your notes for the rhombus, and we find in the green down here at the bottom, diagonals are angle bisectors. In other words, whatever these angles are, it bisects it, okay? Now these two sets of angles, the ones here and the ones here, don't necessarily have to measure the same. Matter of fact, they're probably not. So when they get bisected, you can see I have congruent marks, single and double struck congruent marks, making sure that the reader doesn't believe that the angles over here and the angles over here, the smaller ones, are the same. Okay. Now, since it's a parallelogram, opposite angle are congruent. So when that bisects that angle down there, those things become congruent, and so on. Okay. So if this big angle over here was 120 degrees, each one would be 60. And that would be the same thing down in this area. Does that make sense? All right. All right, let's play a real quick game. What kind of shape is it? Use your characteristics worksheet to help. Okay, so we're going to have to go back to our worksheet that I told you to download and print up, or if you've gotten your packet already, we have it. Let's go back and shade in the characteristics for each shape, and then we're going to come back to these and use them to help us determine what kind of shapes they are, because they're just badly drawn. Okay, so here's the sheet that you can download. The one I have printed up on your packet, similar to this one. It has some bolder lines and stuff in it. But let's just shade some things in real quick. Okay, so just quickly run down the list. You have one pair of congruent sides. Both opposite sides are congruent, all sides. And I'm just going to assume that you can read that. So this is a list of the characteristics. If you look back at what I talked about for parallelogram, what I have highlighted here are the particular characteristics go with a parallelogram. So this is what I know. A rectangle is a parallelogram. Now don't color this in just yet, okay? I'm just letting you understand. A square is a parallelogram. A rhombus is a parallelogram. And a trapezoid, well, it's not a parallelogram. So a rectangle, square, and rhombus all have the characteristics of a parallelogram. Now here's the thing. If you look at the first one here, it says both opposite sides are congruent, okay? But what we'll find out is some of the parallelograms have all sides congruent. So instead of shading this in, I'm going to highlight in this column kind of a higher degree of characteristics. So just follow along with me in this as we fill this thing out. Okay, rectangle, both opposite sides are congruent. Both opposite sides are parallel. Now this next one says opposite angles are congruent. Now that's true, but it's not just opposite angles, it's all the angles are congruent in a rectangle, right? Because they're all 90 degrees. So we're not going to shade in opposite angles are congruent. We're going to go to the next level of idea, and that is that they're all congruent. And of course, this one here is a special feature of a rectangle, that all the angles are right angles. And of course, all the consecutive angles are supplementary. Nothing special about the diagonals bisecting each other, so it's going to share that with the parallelogram. I mentioned the diagonals are congruent, and they're not angle bisectors. So in a square, both opposite sides are congruent, but we're going to go to the next level of idea, and that's that all opposite sides are congruent. I'm sorry, all sides are congruent. Both opposite sides are parallel. All angles are congruent. That's coming from the rectangle. All the angles are right. All consecutive angles are supplementary. Diagonals bisect each other. Diagonals are perpendicular. Now it's going to get that characteristic from the rhombus, which is the next one I'm going to do. Diagonals are congruent. It's taken that one from the rectangle. And the diagonals are angle bisectors. That's going to get that one from the rhombus. And you'll see that in the next line. All right, so a rhombus, which is a little lower order than a square, is all sides are congruent. Of course, it's a parallelogram, so opposite sides are parallel. Now, in a rhombus, not all the angles are congruent, right? That's a rectangle feature, but it does have the parallel feature, or the parallelogram feature, and that is that opposite angles are congruent. Again, a parallelogram features that all consecutive angles are supplementary and the diagonals bisect each other. Diagonals are perpendicular. That's a feature of a rhombus that the square gets from the rhombus side. Diagonals are congruent. Nope, not a case. Diagonals are angle bisectors. That is a case for a rhombus, okay? All right, we'll finish this chart at some point with trapezoids and kites at another point. So here's a quick diagram. So you have quadrilaterals. That's the top of where it's four-sided figure. Any quadrilateral that has two pair of parallel lines, or two parallel lines, that's these here, and that's it. It's called a trapezoid. When a trapezoid has those sides congruent, then it's called an isosceles trapezoid. Another thread of type of quadrilaterals is the parallelograms. These are the ones we've talked about today. And so it has not just one pair of parallel sides, but two pairs of parallel sides. Okay, and that's the feature of a parallelogram. Then it runs off to being a rhombus or a rectangle. And then if we have a shape, a four-sided figure that has both rhombus and rectangle characteristics, it becomes a square. And then we have a kite. And a kite is that it has two pairs of congruent sides, but they're not opposite sides. Okay? All right, so we'll study that in a little bit more. All right, and I talked about coming back and playing this game of what kind of figure it is, but due to the time, I'm going to cut it. We're not going to come back and look at this. So let's talk vocabulary real quick. Hopefully you have your chart or you're going to write this down in your notes. Look at parallelogram, put me on pause, and just copy that information down. And of course, quadrilateral, you want to copy that one down. Now, I should have had you do that one first. Quadrilateral, any four-sided figure. Parallelogram is a four-sided figure where you have opposite sides are parallel. Then comes a rectangle. It's a parallelogram with four right angles. A rhombus, a parallelogram with four congruent sides. So just put them in pause. Make sure you write down that information. Then we have square. It's a parallelogram that has all the rhombus and rectangle information. Basically, the big features are it has four congruent sides and four right angles. Opposite angles are two angles that do not share a side of a quadrilateral. So if you look at the figure, angle A and C are opposite angles, and the red represent the sides that make up angle A. The green represents the sides that make up angle C, and neither one of those shared. Okay, we have a mid-segment. A mid-segment is a segment that connects two midpoints. We'll deal with that in a future time. Consecutive angles in a polygon, two angles that share a side are consecutive angles. So angle A and B are consecutive angles because they share that side of AB. All right, so here's your try it problems. And what I'm going to do is I'm going to actually put this on pause, and then I'm going to you go ahead and do these four problems and bring it in for your homework, of course. But what I'm going to do this time to help out, I think, some people with smaller devices is I'm going to scroll through these so that you can pause and look at them in a little bit bigger format. If you can see this fine, just put me on pause, work these problems. In just a moment, you'll see it scroll through it a little bit bigger font. Okay, so here we go. So at some point, you just put it on pause and write down what you see. All right, have a great day, everyone.